in this video, we're going to be talking about how we can evaluate an algebraic expression. And all an algebraic expression is an expression in which we have letters, which we call variables, paired with constants, and they form mathematical relationships with each other. So an example of this is something simple, probably. Let's do 12x minus 7. So this is an example of an algebraic expression because we have the variable x having relationships with constant numbers like 12 and negative 7, or 7. So if we want to evaluate an algebraic expression, all that means is that we have an x value, just substitute in a number for x and see what comes out of the expression. So let's say we want x to equal 0, and then we want x to equal negative 1. Well, in the first instance, if we plug in 0 for x, we have 12 times 0, which gives us 0, and then 0 minus 7 just gives us negative 7. So when we plug in 0 for x in this expression, negative 7 is going to be the output. And similarly, if we put in negative 1 for x, all we do is we substitute the value of negative 1 in for x to evaluate the expression. So we have 12 times negative 1 minus 7. Well, 12 times negative 1 gives us negative 12, and the minus 7 remains. And negative 12 minus 7 gives us a negative 19. So you can see that we have different outputs of the expression for different inputs of x. And this is going to be very pivotal whenever we study functions. Now let's try another example here. We have another algebraic expression to work with, x squared minus 6x plus 5. And we want to evaluate this expression at the x values of negative 2 and 2. So all we do is we plug in the number that we want in for x in the expression and see what we get whenever we perform the operations. So for the first one, x is negative 2. So I'm going to do negative 2 in for x. So we have negative 2 squared minus 6 times negative 2 plus 5. Carry out these operations. Negative 2 squared, or negative 2 times negative 2, gives us a positive 4. Minus 6 times negative 2 gives us a negative 12. And then the plus 5 remains. So these negatives actually cancel out, so we get a positive. So 4 minus a negative 12 is going to give us a positive 16 because the negatives cancel. The plus 5 remains, and then 16 plus 5 gives us 21. And that's what happens whenever we plug this expression in for, we plug negative 2 into this expression. Now let's go on to the other one. Let's say x is equal to 2. Let's see what happens. So we have 2 squared minus 6 times 2 plus 5. 2 squared is just 2 times 2, which gives us 4. Minus 6 times 2. Now 6 times 2 is 12, so we have not a negative 12, but a positive 12. And notice what the difference is here. So we have 4 minus 12 now, which gives us a negative 8 plus 5, and then negative 8 plus 5 gives us negative 3. So we have two very different answers when the signs change in this expression. So these algebraic expressions are useful for defining relationships between numbers whenever we plug in new ones for each of the variables. All right, we have another example of an algebraic expression. Here we have negative x squared plus x minus 1. And we want to evaluate this expression at the values of x is equal to 1 and x is equal to negative 1. So let's take a look at the first one. And whenever you see the negative sign in front of an x squared, that means that we are taking the negative of whatever number we're squaring, so that a negative stays out in front. So we're plugging in 1 for every place that we see x, and then just solving the equation. So 1 squared gives us a 1, but this negative remains. So we have negative 1 plus 1 minus 1. So 1 minus 1, these cancel out, and we're just left with the negative 1. Now let's see what happens when we plug in negative 1 for x. So negative 1 squared plus negative 1 minus 1. And this gives us a good opportunity to use some sign conventions. So negative 1 squared is just negative 1 times negative 1. When you multiply two negatives together, you end up getting a positive. But we have this negative sign floating out front, as the definition of the algebraic expression dictates. So we have minus 1. And then when you have minus 1 plus a negative 1, so a positive times a negative gives us a negative. So we have negative 1 minus 1 minus another 1. So negative 1 minus 1 gives us negative 2. And then negative 2 minus 1 gives us a negative 3. So again, based on what value we put in for x, we have different values that the expression is going to come to whenever we evaluate it. Okay, one last example. This is an example of a rational expression. We call it a rational expression because we have a term on the top and a term on the bottom. And we have integer expressions for the variables. So when we have two integers on the top and bottom, remember, that's what defines a rational number. So all we're going to do is we're going to plug in negative 3 for x for the first one and see what happens. So we have negative 3 for the x, negative 3 minus 3 on the bottom. We have negative 3 on the top, and then negative 3 minus another 3 gives us a negative 6. The negatives cancel out. Negative divided by a negative gives us a positive. And 3 over 6 reduces to 1/2. Now let's look at the second one, where x is going to be equal to 3. So all we're going to do is we're going to plug in 3 for the x's. So we have 3 on top, and then a 3 minus 3 on the bottom. So this leaves us with 3 over 0. And now we have a big problem because 0 cannot be in the denominator of a fraction because it is impossible to divide something by 0. You would be taking infinite parts out of it. So whenever you see a 0 on the bottom of the fraction, we call that undefined. Pretty sure I spelled that wrong here. Let's get this out. Just mixed up the I and the E there. So the only number that can never be on the bottom of a fraction is 0. And whenever that happens, we say that the number is undefined. And so whenever you want to evaluate an algebraic expression, all that means is that we have a certain number for x that we want to plug back into the algebraic expression. And when you plug it in, all we do is we carry out the operations and see what comes out of it. And that is how you evaluate an algebraic expression.